Hello, everyone, and welcome. This is Aurora with Central Coast Astronomical Society, and tonight we are in for a special treat. We actually have two astronomers on with us tonight. One of them is I'm actually going to introduce both of them to you for tonight. We are going to take a tour of the moon. You know, a lot of people, when they go outside, they look up. Some people notice that the moon changes shape. Other people don't really notice. But we're going to actually do even more. So even just with your naked eyes, or if you have a pair of simple binoculars, you'll be able to use that as well. And we're going to take you on a tour of the moon and see what most people miss. And I am so excited to bring this presentation to you tonight. I know I'm a little bit early. We've got another couple of minutes to go. Before we get started, if you could go ahead and write in the comments right now what part of the world that you are connecting with us from, that would give us a heads up. Whether in the northern or southern hemisphere, you're still going to see the moon. It's going to look just about the same, but it helps us. So when we do our shows, we can pick objects that are in your neck of the woods. So that would be helpful as well. So for tonight, the only thing you need is us. You're going to sit back, relax, enjoy the show. You can do a Google search. We also put it in the show notes as well. Links that are below. There's a PDF of a moon map you can get from NASA. If you just Google moon map NASA, you'll find it. Sky and Telescope also has some. If you'd like that, as we go through our presentation tonight, you're welcome to take a look at that and circle some things. Otherwise, this presentation is super easy, and our goal for you is by the end of tonight, you're going to be able to go outside, look up, and know what you're looking at and be able to point out some things. And I actually learned quite a bit when we did our pre-show, when we did our getting ready for the show. I didn't even realize more than half of those things were visible just with binoculars and with a small telescope. So I'm really excited to be bringing this presentation to you. All right, so we are going to go ahead and get started. Welcome, everyone. My name is Aurora. I am the president of the Central Coast Astronomical Society, and we are so excited to be able to share the moon with you tonight. So we are going to be taking a 7-day tour of the moon with Dr. Lee Coombs, who has been doing astrophotography for 45 years. And he actually told me only in the past 10 years did he start going digital. So a lot of that stuff he said he learned the hard way, but he was so glad that he did it. And he's actually been published almost 1,200 images of his astrophotography, and we're really excited that he's going to lead us tonight. The images that you're going to see are real. These are photographs he actually took himself last month, and so he planned it out and he has everything ready to go. Before I bring him on, there's somebody else I want to introduce to you. So we actually have another astronomer, amateur astronomer. His name is Brian P. Cox, and he has telescopes set up that are looking at the moon. But unfortunately, Brian, what happened?
Yes, clouds happened, Aurora.
Oh no.
Yes.
And so, although we won't be able to see the moon tonight, that's okay. Brian actually did a live moon views through. How am I trying to say this? Live views through the telescope of the moon recently. And so I actually have that video. We're going to share that with you because the moon doesn't change from month to month. So you'll be able to see what we would normally be able to show you tonight. And he'll keep his eye out. If the clouds clear, great. But if not, we still have you covered. So no problem there. All right. So we are going to go ahead and get started. Brian, do you want to introduce yourself to
Yes.
everyone? Hang on a second
Yes.
while I find you. Hang on. You're missing. There you are. Go ahead.
All right, excellent. Hi, I am Brian with Central Coast Astronomical, and thanks for joining us tonight. I will be moderating the chat throughout our time, so let us know those questions. We also have other club members, amateur astronomers, on our chat ready to help answer your questions at any time. And then I'll be saving some of the best questions to pass on to Dr. Coombs after his presentation. Remember that we have that, if you're watching from a smart TV, we have the phone number that you can text. Don't call, we will be answering, but you can text at 805-242-6415 or email questions@centralcoastastronomy.org, and we'll try to hook you up with the answers to whatever you need to know. Thanks,
All right,
Aurora.
perfect. Thank you. Thanks so much. Okay, so are you guys ready for our main presentation? Yes? All right, put a big old grin on your face and let's get started. So I want to introduce you to Dr. Lee Coombs, who is a retired chemistry professor from Cal Poly, and I think I first met him, holy gosh, I must have met you about 15 years ago with Central Coast Astronomy. And I remember even then, I actually have one of your images up on my wall right now. And just your ability to bring things in, using the camera to be able to bring things to life that you can see so much more detail than you can, especially with dark, deep sky objects, which just still blows my mind. And I'm so excited that you're going to be joining us tonight. So I am excited that you're going to take us on this tour of the moon. Are you ready?
I guess I'm as ready as I'm going to be.
Okay, so everyone, please help me in welcoming Dr. Coombs. Yay! If you have any questions for him as we go along, as Brian mentioned, you can text them, email them, or you can put them in the chat. We will do our best to answer them when he is done with his presentation. All right, Lee, go ahead and take it away.
Okay, let me get the share screen things all ready here so that I can share some of the photos. It'll get us through our thing, I hope.
Absolutely. While he's doing that, I should mention at the end, I'm also going to share a quick video that Lee put together of his private observatory. He's been using it for 25 to 30 years. It's got a roof that rolls off and telescopes that stick up. It's amazing. So we're going to share that with you at the end as well. All right, Lee, are you ready?
I'm ready.
All right, let's go.
I hope everyone sees the full moon that's right there on the screen, but I want to do a little bit, say a few introductory things about the moon and how it was formed and some of the major type features, how they were formed that we'll be referring to through our tour. The orientation, as far as if I say something's on the east limb of the moon or something, at least in the northern hemisphere, this is the moon as it would appear with your naked eye or through a pair of binoculars. It's an erect image. So top is north, east is to the right, south. To the bottom, of course, and not to confuse you, but if you can get the orientation of the moon based on the 4 points of the compass, then
hang on a second there, Lee. I think we lost you. At least I did. Can you tell us, can you start back when you were doing the north, south, east, west bit?
Okay. Hi, I thought this is the full moon, and I thought I'd use the full moon as a means to introduce some of the history as far as how the moon was formed and how some of the major features on the moon were formed. I may be pointing out objects based on certain points on the moon. And if you're in the northern hemisphere, the top of the moon, as you would see with your naked eye or a pair of binoculars, would be the north limb, east to the right, south obvious to the bottom, and west to the left end. And that's how it would appear to your eye. Through a telescope, it might be inverted, it might be reversed. So these directions are not always going to be compatible with looking through optical instruments. But for naked eye and binoculars or spotting scopes, that's the way the orientation would be. Okay, now the moon was formed about the same time that our solar system was formed, about 4.6 billion years ago. And a lot of huge impacts were occurring on the surface of the moon. And they formed these huge crater basins. And a lot of lava flooding occurred during this time. About 3.7 billion years ago, it lasted for about 500 million years. And these huge craters, these are remnants of these huge craters that have been filled with lava from the fissures in the moon's surface. And there are many of these. There's another one here, another one here, another one here. So we'll be referring to these in our tour. And of course, we've had the moon has been bombarded with meteors even to today. But for the last 2.1 billion years, cratering was occurring on a regular basis. There was a lot of craters formed. The earlier craters often were covered with lava from these basins. So the only ones that really are showing up that were around for a long time are in these other areas, the light areas, and we'll talk about that in just a minute. But from about 1.1 billion years to the present, we've had a steady flow of meteor impacts. And these, of course, have kind of smoothed out the features. There may have been sharp walls and so forth on these early craters, but they were kind of sandblasted down by all the other meteor impacts that occurred over many billions of years. So the time that it takes for our moon to go through an entire set of phases from new moon to the next new moon is a little over 29 days. So if you look at if you see the first day moon, day one moon, it'd be about almost 30 days later before you'd see that same phase again. We're going to look at just a week's worth of phases, and I've picked a series of phases that would show almost all of the major features on the moon in a 1 week period. And so we'll talk about that as we get into it. One of the things that's kind of interesting is that we, of course, are used to having approximately 12 hours of daylight followed by about 12 hours of darkness. If you're on the moon, you're actually going to have 14 days of daylight followed by 14 days of darkness. So trying to get your internal clock set when you're on the moon is going to be a little bit of a challenge. The Earth's, the size of the moon is about 1/4 the diameter of the Earth. So it's a pretty sizable body compared to the Earth. And these big dark areas that I referred to earlier are sometimes called maria or seas. And so they're named after certain seas, the Sea of Storms, the Sea of Serenity, and so forth, because before the telescope was invented, the ancient astronomers or astrologers actually thought that these were oceans of water and named them accordingly. And of course, we know that they're not. They're big, large lava fields that have been with us for many billions of years. The highland areas, the light areas, are areas that weren't covered with lava and are at higher elevations, and they have many of the earliest craters on them that have been bombarded by many, many other craters. Many have been obliterated from the bombardment they've had. The crust is about 6 or 7 miles thick here in the highland areas, where it's only about 1 or 2 miles thick in the maria or ocean areas. So it's quite these are the major features that you will see just with the naked eye. And many of these seas will identify a number of them. You can obviously identify naked eye or with a pair of binoculars. So let's move on to our tour. And we're going to start with a day 5 moon. Now, you can do this tour any month of the year. It's just you have to know what date the 5-day moon is. And so the easiest way to find that out is to find out what date the new moon is. And there are a couple ways to determine that. If you take a newspaper, for instance, in the weather section, you'll probably see the 4 major phases of the moon, from new moon to first quarter to full moon to last quarter. It'll tell you the date of those particular phases. So for instance, in June this year, the new moon was on June 10th, which means on June 15th, 5 days later, is going to be the 5-day moon. Now, if you aren't taking the newspaper and have access to that, you can always get on the internet and type in lunar phases or something. And it'll tell you the phase of the moon any month of the year, practically into the distant future for that matter. So if you ever want to do this tour with anybody at any month of the year, you want to start the same place we do, that's how you can get the starting date to do your own little tour. Okay, let's move on and look at the 5-day moon. If I have a little problem. There we go. Now let's see if it'll work. There we go. Okay. This is the 5-day moon. This is today, actually during this program, this is the moon phase that's up the sky right now. If you happen to be listening to this today on June 15th, 2021, and you went outside and look at a pair of binoculars in your hand, you probably see this phase of the moon. Now, it wouldn't be this close to you, although a pair of binoculars might get you in there. But there are some features here that you can see easily with a pair of binoculars or even your naked eye. This first is this Maria region or sea region. this is called the Sea of Crises, and we'll see that for the whole tour because it'll be on the east limb the whole time that the tour is occurring. It's a fairly large feature. This distance from one edge to the other is about 310 miles. I live in just outside of San Luis Obispo in Central California, and this distance from here to here would be about from here to San Diego. That's about 310 miles. So it's a fairly large feature, and of course, it's not one of the bigger seas on the ocean on the moon. Now we have two fairly prominent craters up here. The smaller one is Hercules, and the larger one is Atlas, named after the two Greek or two strongmen of mythology. We'll take a closer look at that region in a little while. So let's move in here and see a little closer look. Okay, Hercules is the smaller of the two. This is about 42 miles across. Again, these are fairly large features. So if you can think about distance between where you are and some nearby town that's 40, 50, 60 miles away, you'll get a kind of a feel for how big these craters are. This is Atlas, and that's significantly larger. It's about 55 miles across. And they're both about, if you're standing on the rim of the crater of either one, from here to the floor is about 6,700 feet. So it's a pretty big drop. And many of these craters, as we will see, will be filled with lava. One up here, for instance, obviously has a nice flat floor, which is due probably to lava filling that up after the event took place. And here I go. Okay.
What's so funny? What's so funny?
Well, when my mouse has a mind of its own.
Oh, okay.
It's probably more intelligent than I am. But if I touch it the wrong way, it'll go on to the next slide, or it might go back to another. So if this thing jumps around a little bit, please forgive me. I haven't learned how to control my wayward mouse. So
You're doing fine. You're doing fine.
Okay. All right, let's get to the next phase. This will be a 6-day moon, and usually, of course, you'll be seeing a smaller version, through a pair of binoculars, but I'm going to bring up the thing a little bit so you can see a little more detail. Now, we'll just look at the highlight features here. This crater right up here is named Positiveness. And, Poseidon has to do with the sea creatures, the king of the sea. Then we have a triple crater system down here. This one named Theophilus. This is Cyrillus, and this is Katerina. And we'll say a little bit more about those. Then we see another Mare region, another sea, and that sea is right here. This is called Sea of Nectar, or Mare Nectaris. Mare Nectaris. So it's a sea a little smaller than the one we saw up here, but it has an interesting feature on the side. It looks like there's a crater or something that may have been there and also flooded at the same time that this area flooded. And this is the system that we'll define in a minute, but this is called, let's see, I've lost Fracassatorus, which is a flooded crater. It's about 77 miles in diameter. So this is the kind of a low power view. So let's take a look at it, some of these features a little closer up. Okay, here's our Positiveness. This crater up here has all kinds of fissures and so forth on the floor. Through a telescope, you can see a lot of interesting detail in there. And it's about, like I said, about 60 miles across and about 4,500 feet deep. And it's right by a Maria, which we'll take a look at in a little while. Then we get to the Sea of Serenity, which is right here. And you can notice these little wrinkles in the surface. These, in fact, are called wrinkle ridges. And wrinkle ridges are kind of gently sloping low relief ridges that are less than 800 feet high. You need a real low angle on the sun to see them easily. They may have formed as young lava flows passed over older lava flows, or they may have been formed from compression or expansion of the surface lava. But we'll see a number of these when we are looking at some of the Maria regions in our tour. All right, here we have our triple crater again. This is Theophilus, Cyrillus, and Caterina. And these are all about the same diameter. They're a little over 60 miles in diameter, and they're all about 12,000 feet deep. So if you're on the rim of Theophilus here, looking down at the floor, it would be 12,000 feet below you, which is a pretty long distance. And we already talked about Marinectaris and Brachiosaurus, which is the flooded crater right here in the Maria. All right, let's see what the next day has to offer. So we're getting into a little later in the phases. We're in the 7-day moon, which is getting pretty close to first quarter. We're seeing more and more craters. And our key area that we always want to look, our sweet spot is right along the terminator, right where the bright and dark side of the moon appears. And this is where the sun has a fairly low angle and creates these shadows which highlight the detail in many of these craters. You notice some of the craters we saw earlier in the earlier phases, they are almost indistinguishable now because the sun is almost directly overhead from where they are. And it does not highlight the craters and features anywhere near as clearly as along the terminator. So one way to look at this is the worst time to look at the moon as far as crater detail is during full moon, because you don't have this nice shadow detail in a terminator to highlight the features. Okay, we have a couple of new craters up here in the northern part. This is Aristarchus, this larger one here, and this is Eudoxus, the lower one. And if you remember all these names, then you're a heck of a lot better than I am. But when you get to some moon charts and stuff, you'll be able to identify all of these features very easily. Then we have, again, this is the Sea of Serenity, and many of you may have heard of that before. And I know you've all heard of this sea. This is the Sea of Tranquility. And this, of course, was the site of the Apollo 11 lander where man first stepped on the moon. You probably recall Neil Armstrong's transmission to Earth after he had landed there. He said, "Tranquility base here, the Eagle has landed." And the Eagle is still there, the landing module. Now, I often, when I start pointing out Apollo landing sites, I have people often ask me, well, you know, you have a big telescope. Can we see the lander with your telescope? And the simple answer and correct answer is no, you cannot. And the reason, even the largest Earth-based telescope can rarely discern an object any smaller than about 1,000 feet across. And that's, about 1,000 yards across. So that's like 10 football fields. You'd need a crater about 10 football fields in diameter in order to detect it with an Earth-based telescope. That's about the size of Meteor Crater in Arizona, if anyone's ever visited that crater. That's about the smallest crater you could detect from the Earth with an Earth-based telescope. So the problem, of course, with the Apollo program is, if that's the smallest thing I can see from Earth, how am I going to find a nice smooth landing spot for my 20 or 30 foot lander? You know, so that was solved quite readily by having 5 lunar orbiter missions that orbited the Earth and took photographs, high resolution photographs of the moon's lunar surface. With those cameras, you're able to detect objects as small as 3 feet in diameter. That's 1,000 times smaller than you could see from Earth. So with a 3-foot diameter object and anything larger, they were able to find some safe sites for our landers to drop down to, and not worry about falling into a crater or landing on a ridge or something and destroying the mission. So thank goodness for those orbiter missions. If it wasn't for that, then the Apollo missions would never have taken place. Okay, now let's move in a little bit. And this again is the Tranquility Sea of Tranquility. And I've marked with an X where the Apollo 11 site actually is. This is where the lunar lander still rests, and where Neil Armstrong first set foot on the moon. And you can find that site easily with a pair of binoculars. You just have a little reference map to kind of refer to a few of the craters in the area. This is Theophilus down here, so it's kind of a reference. If you come up from there, you can kind of find that area where the Apollo 11 landed. Okay. All right, on to 8th-day moon. Here we're moving along in our tour. There's an interesting little scrape up here. It looks like this is called the Alpine Valley, and we'll take a closer look at this. It kind of reminds one of maybe a meteor that came in at a very low angle and scraped out this long valley, but that is not how it came about. So we'll learn about that in just a minute. The other thing that kind of I alluded to last time is that we have this huge area loaded with craters. And this is the southern highland area. This and the area that's still in the shadow, it's just loads and loads of craters. Many of these craters were formed in the early stages of the lunar history, but many of them have been obliterated by so much cratering that has occurred. Trying to find a suitable landing site in this region would be probably next to impossible. There's just so much rubble in this heavily impacted area that it's very difficult to select a safe landing site for certainly a manned mission, I would think. There are some that are pretty close to these areas, but nothing in the actual highland areas. So let's take a look at a little closer here. Here's the Alpine Valley, and this is about 112 miles long, and it is called, the geologists call this feature a Graben. It's a swath of terrain that has dropped between two roughly parallel faults. So there's a fault on one side and a fault on the other, and the area between those faults kind of sunk down and left this valley, and then it was repaved with a lot of lava flows and so forth soon thereafter. But it's an interesting feature, and even in low power in a telescope or even a pair of binoculars, you can probably pick that feature up. It's not too difficult to see. Okay, let's see here. I don't want to lose track of where I am. Let me get in here. Okay, that's where I'm. Did my mouse do something to me? I think it did. It took me back to the original.
I think you're good now. I think you're good.
Okay, I think this is where I left. Okay, here's another interesting kind of thing. There's a flooded crater here. You can see the rim of it. Sometimes they call these craters ghost craters, because it kind of looks like just a little bit of a crater. And then there's a little crater inside of this that kind of reminds me of an eyeball. But the little crater inside is called Cassini. And this is a ghost crater, one of many you will see in the Maria regions in particular. So let's move in a little closer, and we get some areas that, here's a challenge for those with telescopes. We have what we call rills, and I'm going to move in here a little closer. And up here you see these spider-like things. These are called rills. Sometimes these fine ones are called sinuous rills. And these are long, narrow ravines or canals that resulted from either magma flowing down these trenches, or they may be collapsed lava tubes where lava has flowed, left a hollow tube after it's cooled and hardened, and then maybe a moonquake or an impact of a meteor or something caused these things to collapse, and you're left with these rills. Then we have some larger rills up here. These are called straight rills. And the difference between the two is that these are formed mainly by faulting, by faults, like San Andreas fault, by the separation of the lunar surface due to earthquakes or whatever phenomena. And you can kind of tell the differences. These things go all the way, they'll go right through a crater, they'll go through a mountain, they go through everything. And the whole surface was split open by this fault. Here's another one up here, goes across here. And it just continues. As a matter of, there's a mountain there, it just keeps, it's still split. It could be a crater, could be any number of things. So you'll see a number of these features, especially in the Maria regions where they're most easily highlighted by a low sun. And a challenge. This was not too difficult to see in a telescope. This is more of a challenge. You need a good steady night. And if you can see that, those of you who have a telescope, here's your challenge. See if you can get a glimpse of that particular feature. Okay, this crater here, by the way, is called a Tresnecker. And Tresnecker sometimes is nothing out of the ordinary. It's a fairly recent crater, but they'll refer to the Tresnecker rills, and these are the rills they're referring to. Can you see those all right? Is that coming through clear?
Yes, it's totally coming through clear. People are loving your images, by the way. They are just completely blown away by the detail that they are seeing.
Well, you can see this all by yourself.
Yes, but you took these images and you're inspiring people.
Yeah.
Okay, keep going.
It's time to go on to the 9-day moon. We're moving right along here. Let me see. I got to drop this magnification down a little bit so that I can get my next. There we go. Oop, see, my mouse is doing it to me again. Let's see that. No. Bear with me, people. There we go. Okay, here's 9-day moon. And mouse, you behave yourself. Okay, again, you can see the Alpine Valley up here. It's still highlighted nicely. The two craters we talked about. This is the first time we actually got a good view of some of the mountain ranges on the moon. There's a mountain range here, there's a mountain range here, and a large mountain range here. These are actually the rims of the original crater that was formed in the early stages of the moon development, most of which have been obliterated by lava flows. But these rims were high enough that they still exist and they appear as mountains. They are not formed anywhere near the way the mountains are on the Earth. They're not by geological forces, but they're merely what's remaining of the rims of some very large impact craters. And like the seas, the mountains are named after many of the mountains here on Earth. These up here are the Alps. It's up there where the Alpine Valley is. This little group of mountain ranges are the Caucasus Mountains. And this really nice range of mountains here are the Apennines. And these are ones that have some of the largest or tallest mountain ranges on the moon that we'll mention in a little while. We also have an interesting crater up here. It's a great big crater that's just got a nice smooth floor to it. So it's a flooded plain, they sometimes call that, a flooded crater. The crater was totally filled with lava, either from its own floor or from the region alongside of it. And then we have an interesting crater again, similar to Plato, and this is called Archimedes. And we'll use that as a kind of a signpost for another thing we'll be looking at. And then down here, we have another series of 3 craters, another triple crater system. Again, here's our first triple crater system right here, which now, as you can see, doesn't look very easy to observe or photograph because the sun is so high above it. It's not leaving any shadows. As soon as you get that nice shadows in here along the terminator, you can see a lot of detail. Anyway, this is a triple crater system, and we'll look at all of these features a little bit more closely now. Okay, here we go. Here's Plato again, and it's about 62 miles across. And even though it's filled up with lava, from the rim to the floor is over 6,500 feet. So the original crater must have been extremely deep. But again, that's a flooded crater, as is our other one here. Now, here's some interesting features. And again, if you have a telescope, I don't know with the binoculars whether you can see this or not, but they're two very tall spire-like mountains here and here. And you can tell by the long shadows that you see from them. This first one is called Pico. And Pico, if you were on the flatlands out here looking this way, you would suddenly see a Pico, which would be jutting up 7,800 feet high. So this towering little mountain of Pico is be quite an interesting sight after walking across this flatland, seeing that. The other is Piton, which is over here. Again, has a nice long shadow, and it's not as high as Pico, but it's about 4,400 feet high, just sticking up out of the Maria there, out of the ocean. The peaks here were probably all part of the rim of this huge crater sometime, but they never got totally buried by the lava in that crater. Here's our eyeball over here again, and here's Archimedes. Now, Archimedes is about 50 miles across, and it's very easy to locate. So we can use that to find another Apollo landing site, which I marked here with an X. And this is the Apollo 15 landing site. And what makes it kind of different from the other sites, from the other landers, is that this is the one that carried the lunar rover. In other words, it's the dune buggy on the moon. And this is where it allowed the astronauts to travel. I know there were 4 or 3 routes they took that covered a lot of territory. And it's still right there. The rover's there, so is the lander. And this is Hadley Rill that goes through this valley. You see a very hint of it here. They, of course, went over to Hadley Rill to see what it looked like. And the lunar orbiters right now can still photograph. They can photograph not only the rover, but the tracks that the rover left on the surface of the moon during those little expeditions. So once in a while, you could probably find that on Google or something. Those probably show you some photographs taken by the lunar orbiter. They can show that kind of detail. But it's a fairly easy place to find. If you find Archimedes, which is stands out like a sore thumb, it's right over here a little bit to the southeast is the landing site of Apollo 11. I'm sorry, Apollo 15. Now, again, this is the Alpine range of mountains, and these mountains, some of these are as tall as 16,000 feet. That's above the level of the Maria here, 16,000 feet. And of course, the original crater must have been extremely high before it was filled with lava. And then there's a little well-defined crater, relatively new crater, called Eratosthenes. I guess that was a Greek philosopher or something. I don't know my mythology very well, or my Greek mythology and other thing very well, but that's a fairly obvious crater. I think you can even see that with a pair of binoculars. But that's right at the end of the Alpine mountain range. And if I drop down a little bit on this, you can see this whole region is loaded with interesting things. And here again, my thing is doing it to me again. Okay, let's go on here. Let's go down to the lower, more of the southern end of the moon, limb of the moon. And here's the triple crater I mentioned to you, I pointed out to you. This is Ptolemaeus, and Alphonsus is the second one, and Arzachel was the third one. And they're all quite different size. You can tell when each one formed because this was probably the first crater, and then this is probably the second because its rim interjects itself right into the other one. So obviously some of it spilled over into this crater after this impact. And I'm not sure, but this looks like it's even newer than these two because the walls are nice and sharp and so forth. So you can tell but just by the overlap of the craters, you know, approximately what order those craters actually were formed on the moon. And then we have an obvious feature here, and this is called the straight wall. And a straight wall is sometimes termed a fault scarp. In other words, what happened is that when this thing was flooded with lava, due to earthquakes or whatever the case may be, either part of this lifted or part of it sank, but it left this long wall behind. And it's not very tall. It's between 1,000 and 1,500 feet tall, but it runs for about for about 68 miles, almost 70 miles from there to there. So, and then there's another features, a real challenge. We'll talk about that just in a little while. And then finally, we have one of the largest craters on the moon that isn't totally obliterated right now. And this is this one right here. This is called Deslandres. Deslandres is about 140 miles across, so it's a very large crater. There's another one that's very close to the same size, but on the Earth-based side, this is one of the largest ones. And of course, it's a very old crater because look at all the cratering that occurred after that was formed. It's almost totally obliterated. A lot of the walls and stuff of this crater have been destroyed by other cratering. So we're in the really high impact cratered region here. So let's move into our next phase. Did I just do something that I shouldn't have done? Let's see here. I think this is it. This is right. This should be the 10-day moon. And I'm going to move up a little bit on this so we can see a little more detail. And a lot of the things we've already seen. This is Plato up here. But we have some new cratering. This is one of my favorite craters right here. This is Copernicus. And we'll see more detail about that. But you can see a lot of the ejecta when that crater impacted the moon's surface was thrown out across the moon's surface. And it's a very nice, it really looks like something really impacted and blew it away. This is Aristophanes here, which we saw earlier along with the Alpine range. And this is one of the largest Maria regions or largest seas. This is Marnubium, which is the Sea of Clouds. And it's one of the largest Maria on the Earth side, facing the moon, facing the Earth, I mean. And we've identified many of these features already. And we'll look at a few more over here that are in the shadow in just a moment. Okay, so there's Copernicus. Come down here and we have a few other interesting craters, but one of the ones we're going to spend a little bit of time on is this one here. This is called Tycho, and it's not, it's fairly new. It's one of the newer large craters on the moon. It's only about 100 million years old, which moon age is pretty recent. But its impact must have been tremendous because it's thrown all this debris, all of these rays you see coming out from Copernicus extend a long way across the surface of the moon. And I'll say a little more about that momentarily. And then we have one more very large crater down here. This is comparable to the one we just had. This is called Clavius, and it's again one of the largest craters on the moon. So we'll see a little more detail of that too. But we're starting to see a lot of interesting new detail along the terminator here, and lots of crater in the southern hemisphere of the moon. Oop, got to get down here. Get down, boy. Okay, here we're down the southern hemisphere of the moon. This is the Clavius again. I'll move in a little bit closer. One of the interesting features is there's a circlet of 5 craters right inside the Clavius. This is right in fact, obviously way after the clavius was formed. It's such a large crater that if you stood on this rim, for instance, and looked across to see what that rim is, you wouldn't see that rim because it would be below the horizon. The curvature of the moon is such that from between here and here, that would be below the horizon. Of course, there's a lot more curvature on the moon because it's a much smaller diameter object, but there are lots of little craters. These should be visible, with a good spotting scope or even easily with a telescope. Binoculars, possibly, I don't know, try it out. It's a good challenge. And then those telescope people that have astronomical instruments, see how many little craterlets you can see on the floor of clavius. There are lots of little craterlets, and it's a good measure of how good your seeing is. And again, here's Tycho again, and you can see a lot of the rays coming off from Tycho. And we're in the fun zone here. And we'll take a look at a little closer up. Here's Copernicus. Oops, there I go. I moved my mouse and it did it to me again. Shame on you. Please bear with me. We'll make it. There we go. Okay. Copernicus. This is, it's about, it's not a huge crater, it's 60 miles across, but it has kind of terraced walls on it. You can kind of see the terracing here on this side. So even though it's quite deep, this is over 12,000 feet from the rim to the floor. It's terraced, so it's kind of a gradual decline to get to that. It's not an easy slide. It's pretty steep here, but it's not just a sudden drop off to the floor. And it's a fairly recent crater. Obviously, it formed long after the lava flooding occurred on the moon. So it's pretty easy to locate. And then if we go on to Tycho, okay, here we go. Again, this is Tycho here. That's one of the more recent craters in clavius. We can also see what we just saw in the last phase is the straight wall. Let me just move in here just a little bit. Oop, there I do it to my again. Doing it again. Okay, we'll try it again, see if it works. There we go. Okay. All right. Let's see. Let's get to the next one. Sorry. There. Oh boy. Let's see. Okay, there we are. There I did it to me again. Please bear with me. There'll be a short intermission.
Sure. No problem. No problem.
There'll be a short intermission. Okay. Let's see if I can do this.
Did you get it? There we go.
Okay, now see if I can move it down without tickling my mouse too much. Let's go one more shot here. Okay, this is a straight wall. We saw that in the previous phase. This is a little crater called Burt. And here's your challenge, those of you who have telescopes. There's a little rill that goes right off of Burt here, right here. You could just make it out on this photograph, but that's a good challenge. If you have a good steady scene and you happen to be looking at the moon during this phase, take a look at the straight wall and see if you can see this little rill that's coming away from Burt. So that's a challenge to you amateurs who have your telescopes. See if you can pick that out, just west of the straight wall. Okay, well, go back. We're getting close, folks. Our tour's almost over.
Yeah, you're doing an amazing job. People are so impressed by the resolution of your images.
All right, now we're getting close. We're getting up to, this is an 11-day moon. So this is essentially the 5th or 7th day of our tour. We started with 5, 6, 7, 8, 9, 10, 11 days is the 7th day. So this will be 1 week after you started your tour with the 5-day moon. You'd be right here. Now you're not quite the full moon phases, but you're getting there pretty bright. The moon will appear extremely bright to you because these highland areas just really reflect the sun to our eyes very effectively. And even with binoculars, it's extremely bright. And through a telescope, it's almost painful. So there are ways you can, if you have a pair of dark glasses, you might even look at the moon with a pair of dark glasses. If you're using binoculars or a telescope, it might help cut the glare down a little bit. But you can see how Tycho here, you can see the rays very clearly now. They're really stretching out over a tremendous area of the moon. These particular rays go to about 1,400 miles, somewhere as much as 1,400 miles away from the impact. So way the heck over here. And that's about half the distance from the west coast to the east coast. That's how far this debris was flung across the lunar surface. And you say, well, how come how could it go so far? Well, the impact must have been tremendous. But of course, the gravity on the moon is only 1/6 the gravity on Earth. So things have a tendency to go much further. When you throw a baseball, it should go quite a bit further than it would on Earth, because the gravitational pull on that ball is much weaker on the moon than on Earth, and it would travel a much further distance before it finally hit the ground. So this is, again, a feature that, especially when you get close to the full moon, where the Tycho and its rays become a real obvious feature on the moon. And these ray craters, two of which you've seen now, one from Copernicus and here in Tycho, are quite evident when you're getting close to the full moon phases. There's one other thing, one other feature. If we go to the next day, I'll just peek one day further. But before I do that, let's go and look at some of the close-up stuff here on the 11-day moon. This again is Mare Imbrium, one of the larger Maria, just part of it. This is Tycho, I'm sorry, Plato way up here. Talked about that. It's a flooded crater. This is obviously part of a crater that occurred about the same time. And this particular feature is called the Bay of Rainbows, or Sinus Iridum. And these bays, which the ancients thought were bays in the ocean, are again just remnants of very large craters. Also, we have some of these wrinkle ridges here. You can see some of them here and here. You may have seen some in some of our previous photographs. So some of the wrinkle ridges are easily seen in this area, again at a very low sun angle. So it's very close to the day and night terminator that you see. These features are not very high up, so it takes a very low angle of sun to produce any kind of a shadow. There's another little straight range of things here. This is called the straight range, actually. And this is about 52 miles long from here to here, kind of an unusual feature. And the average height of these mountains are about 5,900 feet. So again, this is probably the huge crater that originally formed this impact zone that's also kind of sticks out on the Maria. Okay, let's see what our next surprise is. Oh yes, a little bit toward the east, toward the west, is another large crater. This is called Gazendi, and it has kinds of rills and stuff on the floor, lots of debris and things that have occurred here. So a lot of activity taking place at that time. All right, now I always like to push my luck a little bit. Oop, I'll get that back up here. Okay, we're gonna go one more day. We've done 7 days. This will be the 8th day. Once you get close to the full moon phases, we're on the 12-day moon now. 2 more days from now, from this picture, you'll be at the full moon. But there's a feature here I wanted to point out, actually a couple of features. The bright spot right here. This is a crater called Arcturus, and it is the, I'm sorry, this crater's called Aristarchus. I'm looking at the star, not the crater.
I was wondering.
yeah, this star right here fell right into the atmosphere.
Okay, say the name again one more time for us.
Aristarchus. And this is the brightest feature on the moon, on the side that faces the Earth. You can even see this bright spot during this lunar eclipse. When everything's in the Earth's shadow, you can still see this sticking out, glaring at you. So when you get close to the full moon, even with your naked eye, and certainly with a pair of binoculars, if you look over at the west limb of the moon, you'll see this bright spot highlighted against the dark maria. This is Aristarchus. And if we move in a little closer to that, there's a valley that snakes around. This is the Aristarchus is right here. And this valley goes through here. This is called Schroeders Valley. And it's mainly a lava flow. This left this long valley during the flowing process. There was volcanic activity and so forth in here. And it's an interesting feature. And it's just easily highlighted against the maria in this region of the moon. And here's one more raid crater. This is called Kepler. So Tycho was the really bright one. Copernicus is the next very large raid crater. And all this is ejected from that. And this is a smaller crater, but the ejecta is easily seen against the dark maria region. This is Kepler. So Kepler and Copernicus, and they're kind of interrelated. They're both old astronomers who had many things discovered through their eyes. Okay, you know what? I don't think I have anything more for you. I could keep going, but then if you want to see this whole tour again, you can get to the 5-day moon next month, or you can start tonight, since it's a 5-day moon, and you'll have a week's worth of fun to locate these objects and discover a lot of your own objects. If you'll see things, you might want to make little drawings of them and then get some kind of a moon chart or a moon map and identify whatever you can see. But you'll always have the moon up there to look for these objects. And I encourage you to use whatever you have in terms of optical equipment and see what you can see. And I think you'll see a lot. So I hope you enjoyed the tour, and I hope you take the tour. You can jump in at any day, say you're out and it's foggy all month, but all of a sudden here it's clear. I got a beautiful moon, and it's the 6-day moon. So I'll go to the 6-day part of our tour, and you can go and look at all the things we looked at here and see if you can find those yourself.
Awesome.
So,
oh, wonderful. Well, thank you so much, Dr. Coombs. I can't thank you enough for taking the time to take us on a tour of the moon and really see a lot of detail. Those images were amazing. Brian, I wanted to open it up and see if you had some questions that we could answer. And then also, we wanted to show you some of Brian's setup where he's going to show you a live tour of the moon that he had done previously because it's currently cloudy. So so we're gonna take a look at that as well. But Brian, do you want to do some fresh questions first?
Yes, I have 3 questions for you, Lee. So the first one would be, when we consider that there's a new moon and full moon every month, why don't we see a lunar eclipse every month?
Okay, well, the orbit that the Earth makes around the Earth is on a tilt. So it doesn't pass through that same angle, the Earth, every month. So if you can imagine an orbit that is tilted and would pass over a different part of the Earth every rotation, there will only be a couple cases where it would fall exactly between the Earth and the Earth's shadow. So the Earth's shadow misses the moon most of the time in its orbit, but occasionally it actually passes through the Earth's shadow and we see a lunar eclipse.
Aha, very good, thank you. The next one would be, you mentioned during your tour ghost craters. How did they get that name?
Well, mainly because that they just didn't, the whole crater wasn't there. Most of it was buried in lava, but you could see the lava passed over the rim and filled up the lower parts of the crater and just left either a semblance of a rim or kind of a memory of a rim that the lava traced out. So it's kind of a ghost of what the original crater was. And that's what you see it's usually you see these in the maria regions where they've been covered with lava, and lava is upwelled there at the ridge of the craters, and left kind of a ghost image of the crater itself.
Very good. Thank you. All right. So the last question I wanted to pass on to you, since there's no sea level on the moon, what's the frame of reference for crater depth and mountain height on the moon?
Well, a lot of the heights of things are determined by the angle of the sun and the length of the shadow. So it's kind of a geometry type problem, a trig problem. You have the angle of the sun. The length of one side, and the angle. So the object is the straight side of the triangle. Knowing the length of the shadow and the angle that the sun is hitting the top of that object, you can use geometry to figure out what the height of that object is. That's one way. There may be others.
Gotcha. I was thinking it may just be from the sphere closest to that particular object. They're just measuring from that distance, either up or down into the ground.
Yeah, I know the early ones are just by shadows, just geometry, but we know what the surface distance is from one limb to the other. We can certainly get a frame of reference for the distances, but we can't send astronauts on the moon to measure heights of mountains and things.
Yes.
It'd be a waste of time.
Just send them around with a giant tape measure.
As far as today, the orbiters and stuff would have very good data in order to calculate heights of different features on the moon.
Wow, very good. All right. Well, thank you very much.
Well,
those are great.
Yes, awesome. Thank you so much. And one last little treat that we had for you is I actually have some video of a live stream that we had done a couple of months back where Brian shared some live videos of what it looks like to look through a telescope. And he had that image projected or piped back into his computer, and then we were able to share that. And so I thought you might like to take a look. So if there were no clouds, this is exactly what you would be seeing. Brian, how old is this moon here? Let me bring this video up for everybody. There we go. I don't know if you can see it there, Brian.
Yes, I can see the image.
Okay.
And well, what I could say is the first thing I know is this is a 66% illuminated moon, and I need to bring up my calendar to find out exactly what age it is.
And yeah, so tell us a bit about how you took this and
absolutely.
What you're showing.
So what this is from a video camera that's connected directly to my refractor telescope, and I'm using a program called SharpCap. And this would be the same setup that I could use to start taking astrophotos, let's say, of deep sky objects. And so what I was doing here in this little video clip is I was setting up the proper exposure, and refractors, right, invert an image upside down. So I was using my program to try to make sure I could get the correct orientation for the moon, so we could see north is up as far as we're concerned. And then with these additional settings, I'm able to adjust, like I mentioned, the exposure, the contrast, to try to get the best image. And you may notice you see a little bit of a ripple going across the face of the moon. And that's because the Earth is still cooling when we capture this image, so that those heat waves are literally moving through the atmosphere, refracting light and causing those ripples as we go. And that's one of the joys we have with anytime we're doing live views, especially right after sunset, is that Earth is cooling for a while and we get to see those ripples.
Yes, awesome. Well, thank you. Well, we actually have that video. Oh, wait, where am I? Here I am. We actually have that video available for you as well. You could take a look. It's a half-an-hour presentation that Brian did as well. So we'll make sure that's available for you as well. Okay. Well, I wanted to thank you, Dr. Coombs, for being with us tonight and for sharing your expertise and your knowledge and your amazing photographs. I think I can speak for everyone by saying those were incredible. So thank you so much. And Brian, did you want to mention anything about the website?
Yes, I do want to be sure to remind everyone, don't forget to visit centralcoastastronomy.org and take a look at all of our features we have there. We're going to be taking the month off from our virtual stargazing events. We had our most recent one just last Saturday on June 12th. We'll be posting new events. Be sure to follow us on Facebook, subscribe to our YouTube page, and don't forget to visit our club store. Many of Dr. Coombs' images that he's taken of deep sky objects, we have available on t-shirts, and all of our products that we have, every astrophoto was taken by club members. So we have coffee cups and real sized coffee cups, not little tiny things, but nice big coffee cups ready for all night stargazing, lots of coffee. So be sure to visit that, and they'll make excellent, let's say graduation or Father's Day presents, I would say. And then you can even start your Christmas shopping now.
Okay, that was perfect. Okay.
You missed her calling.
I actually received an email from a fellow club member she said that she's just going to start sending out links to her family members to our club store so that she can start getting Christmas presents.
That's awesome. I do want to reiterate that we are just going to take a little bit of time off, and we've been going for 16 months straight, which is really our pleasure. And we're also going to take a little relaxation and do a couple of our own special projects this summer. But we will be posting some stargazing videos for you for July as well as August, and then we will be back, and you guys will be able to stargaze with us as well. But we will be posting content for you as well, even when we're not live. So, but we want to thank you for joining us. You're the reason that we're here, and make sure you subscribe and you are follow us and like us and all that kind of. You know how to do all that social media stuff. And if you don't, I'm sure there is a teenager that can show you how. So we can spend some more time together. And thank you so much for sharing the night sky with us. And again, thank you, Dr. Coombs, for your sharing the night sky and your expertise. Thank you, Brian.
Well, very welcome. Thank you. Thanks everyone for joining us.
Yes, and thank you to all the CCAS members who helped. Dave Majors, I saw, was on there, as well as others for helping answer those questions as they were coming tonight. So if you have any questions, you can always send us an email at centralcoastastronomy.org, and we would love to connect with you, and I will see you at the next event that we have. Thank you, everyone. Take care. Bye-bye.